Assalamu alaikum everyone. Today we are going to discuss about COMSORT. So first of all, what is COMSORT? COMSORT functions by comparing elements with a certain gap, which is known as the shrinking factor between them. This gap is reduced in each iteration until it becomes 1. It is an improvement over bubble sort in a way that it does the comparison by a shrinking factor, and it does not compare every element in each iteration. For example, we have an example, an array which has like 50, 40, 30, 20 and 10. It is an unsorted array, and we are going to sort it with the help of COMSORT. So gap is taken as the number of elements divided by the shrinking factor. Here we have the number of elements. We have 5 elements, so 5 divided by 1.3, we have 3.8. We just take the integer part and ignore the float. So first of all, we compare the first element with the element at the gap. For example, A0 and A3. If A0 is greater than A3, then we swap them. In this case, in this example, 50 is greater than 20, so we swap them, and the updated list is 20, 40, 30, 50 and 10. Increment the starting position from 0 to 1. Then in the next step, we increment the starting position from 0 index to 1 index, and also increment the position of at gap by 1 index. So we compare A1 and A4. So 40 is greater than 10, so we swap them. The updated list will be 20, 10, 30, 50 and 40. Then we move to the next step. If we move to position 2, there is no element into position 5. We incremented the position 1 with 1, then we got at position 2. So there is no element at the other end, if we incremented the gap which was at position 4, when we incremented it to 5, so we don't have any element at the 5th position, so we ignore this iteration. In the second iteration, we will reduce the previous gap by 1.3. For example, the previous gap was 3, so 3 divided by 1.3 is 2.3, and we take the integer part. So compare 0 element and 2, the element at second at index 2. Here we have 20, index 0 20, and index 2 we have 30. So we compare them. If 20 is less than 30, then so we have no swapping. Now we compare 1, we increment this 0 by 1 and this 2 also by 1. So index 3 and index 1. So 10 is less than 50, so therefore no swapping here. Now we move on to the next one, increment this one by 1. So now we have A2 and A4. 30 is less than 40. 30 is less than 40, so we will have no swapping. Now 3 and 5, no element at 5, so we'll just ignore this iteration and we go to the next one. In third iteration, divide the gap again by 1.3. 2 divided by 1.3 is equal to 1.5. Then we take the integer part of it. For example, we have here 20, 10, 30, 50 and 40. At this stage, it acts as a bubble sort. Like we will compare each element with the next one, then with the next one, then with the next one. For example, here we have A0 and A1. 20 is greater than 10, so we swap them, and the updated list will be 10, 20, 30, 50 and 40. Then we move to the next one. We increment the 0th element by 1. For example, we have A1 and the gap element by 1, so we have A2. 20 is less than 30, so therefore no swap. Compare A2 and A3. 30 is less than 50, so no swapping. Here we will have a swap. Compare A3 and A4. 50 is greater than 40, so we swap them, and the updated list will be 10, 20, 30, 40 and 50. When the gap value is less than 1, stop and the list will be sorted. When the gap value becomes less than 1, for example, if in the next iteration we divide the gap, which was 1.5, if we divide 1 by 1.3, then it will be less than 1. So actually we stop there. We do not go below the value of 1. For example, the code example can be, we have a class which is named as comsort. We have a method void comsort, and this takes like an integer array, which is nums. Int gap is equal to nums.length. Float, the shrinking factor is 1.3. It is a standard Boolean step. It is like a flag for us, and we set it to false. While gap is greater than 1 or swapped, if gap is greater than 1, then gap is equal to int gap divided by shrinking factor. Swapped will be false. For int I is equal to 0, I plus gap is less than nums.length and I plus plus. If nums at I is greater than nums at I plus gap, then swap nums I and I plus gap, then swap will be true. In the best case, we will have big O of n log n, and in the worst case we will have big O of n square, which is same as the bubble sort. That is it for today.